Welcome to BasicalE. We are starting a new session called PCB Design Guidelines. Through our upcoming sessions we are going to explain what are the basic and general guidelines we need to follow in the PCB designing process. In this session we will give an insight on the general steps involved in the design flow. Step 1 is initial design review. Before starting the design of a PCB, much preliminary information must be gathered and assembled into a consistent package. The purpose of the initial design review step is to get most of this preliminary information in an orderly, complete way. Step 2 is footprint creation. Creates footprints and pads stacks of components as per the manufacturer's specifications and library standards. Those are the fundamental building blocks of PCB. And then it was reviewed and stored into a parts database. Step 3 is integration. Integration is the process of importing netlist exported from the schematics into the EDA tool. Step 4 is pre-layout interview. In pre-layout interview between board designer and engineer discussing the design at the initial stage of the process. Through this board designer can understand and collect initial information like mechanical specs, thickness of the PCB, number of layers etc. The pre-layout interview will help to establish the rapport between the design engineer and board designer. Step 5 is mechanical definition. In this step the outline of the board is defined. Sometimes the outline dimension will be given by the customer, but sometimes board designer need to define an optimized dimension based on the component density and placement. Along the board outline designer need to define the keep-in and keep-out areas, location of mounting holes, origin of the board etc. Step 6 is placement and review. Placing the components on the board is the most important part of the design process. The board designer needs to familiarize the schematics, net rules, and application or reference note by the manufacturer. After the placement, the design engineer reviewed it for the manufacturability and test. Step 7 is pin swapping. For the routing convenience sometimes it's necessary to do the pin swapping. Before doing it, be sure to consult the date sheet of the part and verify the pinouts and ensure it is capable or not. Step 8 is power and ground routing. At the first stage of the routing process the power and ground of the component are needed to route first. Step 9 is critical signal routing. The critical signals like clock and high-speed signals need to be routed after completing the power and ground routing. Step 10 is low-speed signal routing. After the critical signal routing, the designer can route the rest of the low-speed signals. Step 11 is cleanup and review. After completing the routing the designer should each layer individually, and as well as all layers collectively to look for obvious areas of the routing that can be cleaned up. And also the need to do the text cleanup on the board. Then the board sent it to the designer for the review. Step 12 is pre-delivery review. It's the final review done by the customer or designer to ensure all the design requirements are considered and done. Step 13 is final extract and review. After all reviews are completed and final approval has been obtained, it is time to generate final output data. Those are the deliverables for the manufacturing and assembly. The extracted output files are then reviewed by the designer and create zipped archive then sent to the vendor for manufacturing and assembly. We are expecting that this session will give you an idea on the general PCB design flow. If you need any clarifications or have any doubts, please put it on the comments, we can discuss. And thank you for watching us.